Okay, we move to the next presentation that will be given by Cécile Martin about the work on biomarkers and proxies.
So hello everybody. So I'm pleased to present you the work we did on proxies to predict feed efficiency and its determinant in cattle. So this presentation was prepared with colleagues from INRAE and CRA-W. So the global objective of our work was to reduce constraints on experimental animals according to the 3R rules in research infrastructures, and to strengthen cattle phenotyping capacity for large-scale study, and also to find alternative methods to estimate K phenotypes measured with gold standard method or reference method. So the solution proposed was to evaluate proxies of feed efficiency and its determinants in dairy and beef cattle across diets and individuals. And proxies was defined as indicators measurable in easily accessible matrices and easier to implement than the gold standard method. So our strategy was to, and the core of our strategy was to build a large and representative database from the European breeding condition as far as possible, with individual observation, including phenotypes of animals, aligned with the proxies we needed to predict the phenotypes, and this for beef and dairy cattle. And this was possible by sharing data and samples among the SmartCow collaborators, represented by, of course, the SmartCow partners. They are on the first line, but also parties outside the SmartCow consortium, like TNR applicants, including private companies and other research institutes who share data and samples. So I would like to thank all for playing the game and sharing data and samples with us. So which proxies for which phenotypes? So you have the phenotypes on the left we wanted to predict, and on the right the proxies of interest to predict these phenotypes. And at the bottom of the slide you have illustrated the different matrices in which proxies were analyzed. So today I will present you data on 3 phenotypes: feed efficiency, total tract or organic matter digestibility, and methane emissions in relation with the 4 proxies in color, so 15 nitrogen, urea, and spectra from near-infrared and mid-infrared spectra. So let's start with proxies to predict feed efficiency in beef cattle. So you have in blue the 2 metrics to estimate from feed efficiency, so feed conversion efficiency and residual feed intake. And under you have different parameters we need and the tools we need to make the measurements with a gold standard method. In the middle, the target animal, and on the right, the different proxies and the matrice used to predict this phenotype. So first results with 15 nitrogen and feed efficiency. So I present here for this phenotype only the feed conversion efficiency data, but the same trends were observed for RFI, and also the same trends were observed for nitrogen use efficiency. So you have of the graph in the y-axis feed conversion efficiency in kilogram per kilogram, and on x-axis or 15 nitrogen abundance in green and plasma urea in blue. And you can see from the smiley that the prediction are better with 15 nitrogen than with plasma urea. For the overall relationships, but also for the overall relationship, 1 point is one animal, and all the diets are presented. And on the right, you have 1 point is the average of animals by diet. 15 nitrogen also allows to discriminate different individuals with a minimum detectable detection of 0.06 kilogram per kilo. So this is not too bad, but probably not enough for assisting genetic selections. However, it was possible to distinguish to form two different groups of animals from their 15 nitrogen values, with 25% highest and lowest, and between these two groups, the difference of feed conversion efficiency, of 0.03 point was significant. So this is an interesting concept that we would like to propose, perhaps for precision feeding. So now, an example of proxy to predict total tract digestibility. We have studied implicitly the chemical composition of feces for the near-infrared spectra in beef and dairy cattle. So the data we have collected during the SmartCow project was divided in two datasets. One dataset, so 380 data, was used to build an equation of calibration, and the other set of data, 96 data, was used to as an external validation dataset. And if you have a look on the parameters from the relation between the in vivo organic matter digestibility according to the prediction from near-infrared spectra, we can see that the relation is the R square is good, 0.8, and the error of prediction is around 1.9 for the equation of calibration, and the same for the validation dataset, 1.6, which correspond to a minimum detectable detection of 6.6%, and this 6.6% is close to the accuracy of the gold standard method, estimated here to 5.2%. So fecalness has a good potential for as proxy to predict organic matter digestibility in cattle, and it's also a good alternative to gold standard method using stalls, and which are constraining for the animal. So now, prediction of methane emissions. We choose two proxies based on infrared spectra. So the first proxy study is the milk mid-infrared spectra, so for dairy cattle. So in this work, on this slide, you have presented the data, how we use the data collecting during the SmartCow project. So we collected 238 data measured in respiration chambers, and we use this data as an external validation dataset to test the robustness of an existing predictive models published by our Belgian colleague. And you can see that the residual error of the validation dataset is close to the existing the calibration equation. So that's a good point, which confirms that the good potential of milk meal infrared spectra as proxy for methane emissions, and the high throughput approach allows methane phenotype to be incorporated in dairy cow breeding programs. The next step on this proxy is always to include more reference data not yet represented in the database. And what we observed also during SmartCow, it's that we have more and more data coming from green feed as a new tool to measure methane emission, but it's not possible to merge green feed data with other reference data set from respiration chambers and or SF6 without including noise in the model, and a specific model that, based on green feed values is in progress. And the last proxy, so to predict methane emissions, near infrared spectra from feces. So it's an innovative proxy. We collected during the project 400 data, and we used this data to. This data came from a nice complementary data set because we came from different countries and different races fed with different diets. And the first model of prediction was not too bad, with an error of prediction of 52 grams per day. So results are promising and encouraging, especially from an indirect proxy such NIRS from feces. But this proxy is useful for non-lactating cattle, so beef, but also calf heifers and dry dairy cows, because they don't produce milk and it's difficult to have milk infrared spectra from these animals. Of course, more reference data not yet represented are needed, with other breeds, other diets and physiological status, and also with standardized protocol for sampling and dataset management. So this is for the results. Concerning the impact for research infrastructure, it's the improvement of the cattle phenotyping capacity while implementing the 3R principles and research recommendations. And we propose to record in an open access guidelines in the book of method the instructions for using proxy according to a common and standardized protocol. The impact for stakeholders, academic stakeholders, of course, it's production of knowledge and publication, and the production of innovating concept to test them in pilot studies. And for industry, it's the development of phenotyping tools for feed and breeding industry. Future prospects in 3 points. The first, to enlarge diversity of the reference data sets, to update models following research recommendation, to continue investigating new proxy and their combination to improve prediction. And the last prospect is the adoption and the implementation of this research proxies by different actors of the livestock production. And the key of success for this prospect is a strong collaboration network, and by using common guidelines for measurement and data recording. Thank you.
So thank you very much, Cécile, for this nice overview of all the work that was done on proxies and biomarkers in the project. I'm sure this will stimulate questions. Yap is always our first.
Thank you, Cécile. When you started your presentation, you said we have phenotypes or traits and we search proxies for it. And basically, when you presented the results, it's a one-to-one relationship. Would it be interesting to see also if can we measure a large number of proxies? And does it tell anything about some traits? In some cases, you may need 2 or 3 proxies to predict well. So is one proxy the holy grail, or should we look at numerous proxies that will tell something about the animal, and we'll see what comes out of it?
Yeah, it was. It's one point we mentioned. Sorry, it's one point we mentioned in the perspective to combine proxies. In fact, so we start this work. Gonzalo study the combination, for example, or urea and 15 nitrogen, I think. But we can also increase strengthen the models with phenotypic data from the animal also. So it's what we would like to do, of course. But we just have to keep in mind that we have models for research and models for field. So if we increase the complexity of the models, they won't be used in field.
Thank you. I can see a comment and a question in the chat. Very good work. Have you published your work on methane?
Work on methane. So there is already a publication from the Belgium group for prediction of methane with near-infrared spectra. We have published some abstract on the new dataset validation, and concerning the near-infrared spectra, it's from thesis. It's published and would be published in Congress, the next EEEP, and in close future, the publication will arrive before the end of the year, so soon.
Okay. Thank you. There was a question about the previous talk, but I think from Mathieu about nitrogen balance at grazing, but I think some data.
I think that's about the nitrogen in 15 abundance. Yeah, I think that's about the.
So Chris, maybe you can comment on this question?
My interpretation of that question, René, is it applies to the N15 discrimination.
Okay, sorry.
An estimate of feed efficiency or nitrogen efficiency.
Oh, sorry. Yes, you're right.
Grazing cattle.
It's for me or it's for...
Yes, I think it's for you, Cécile. Is there a study using the N15 on grazing cows to measure feed efficiency on grazing cows? For you or maybe for Gonzalo?
Yes, because we need gold standard methods to establish predictive equation. We only include trials with indoor conditions where feed intake has been daily and individual recorded. So for developing these models, we don't use animals in grazing conditions, but once the predicting models are established and validated, we can propose them for predicting nitrogen use efficiency and feed efficiency in grazing conditions.
So thank you. And I can see another question for you, Cécile, from Nicolas Friggans. For the methane, you suggest that the fecal NIR be only used in non-lactating animals, but given the lower accuracy of prediction in the validation set using milk mid-infrared, I was wondering how good the fecal NIR was for dairy cows.
We use for both.
Please, in the microphone.
Yes, we study also the relationship for dairy cows. and we plan to mix both, perhaps both milk infrared spectra and infrared spectra from feces. But the interest of feces is more for beef cattle.
Mm-hmm. Okay. And
do you want to add something, Emily? It's okay.
And I can see another question in the chat from Surya Binti Mohamed. Thank you for your presentation. I could see only the data from green feed respiration chambers and SF6. What about from high throughput measurement tools like the infrared sniffer? Do you have such data? Include that in the validation model development? So the infrared sniffer for methane measurements.
We don't have in our database.
Is it all, because we had a TNA about the laser methane?
Oh, it's not the same thing.
It's not the same thing.
Yes, it's another tool.
Another tool. Okay. And what do you think about this tool?
All the best. No, but it's SF6 and respiration chambers are direct methods of measurements. Green feeds are direct methods, but with spot measurements. And the other laser and sniffer for me are indirect methods of. So it include another noise in the predictions.
Yes.
But why not? It's possible to do.
Of course. But it needs more calibration and validation.
Yes.
Okay. If there is no other question, I think we are just on time.